Welcome to the video. In this video, we are going to discuss about chapter 1 of class 10 chemistry, chemical reactions and equations. What are chemical reactions? The process of converting reactants into the product is known as chemical reaction. A chemical reaction is a process where the reactants gets converted into the product. So in a chemical reaction, there are reactants and products. What are reactants? The substances which take part in a chemical reaction are called reactants. And the substances which are formed in a chemical reaction are called products. In a chemical reaction, the reactants are converted into the product. Next, how can we represent a chemical reactions? A chemical reaction can be represented by different methods. First, by word equation. A word equation shows change of reactants into the product through an arrow placed between them. Generally, the reactants are written on the left hand side, LHS, with a plus sign between the reactants. And the products are written on the right side, RHS, and with a plus sign between the products. The arrow head points towards the products and shows the direction of reaction. So a chemical reaction can be represented by different method. First one, a word equation. A word equation shows change of reactants to the product through an arrow placed between them. On LHS side, it is reactants. On the RHS side, it is product. Next, how do we identify whether a chemical reaction takes place or not? A chemical reaction can be identified by observing certain changes. Change in state of matter, or change in the color, or evolution of some gases, or change in temperature. So in every chemical reaction accompanied with a certain changes. Sometimes change in the state, like states like solid to liquid. For example, when you heat some materials, they converted into the liquids. Sometimes the change in, you can observe change in color or evolution of gas. When we do electrolysis of water, hydrogen and oxygen get liberated at different electrodes. And we learned that in class 9, we learned that every chemical reaction, during a chemical reaction, mass can be neither be created nor be destroyed. So this is the law of conservation of mass. During a chemical reaction, mass can neither be created nor be destroyed in a chemical reaction. So the mass of the reactants, the sum of the mass of the reactant should be equal to the sum of the mass of the products. So a chemical reaction should be balanced. What do you mean by a balanced chemical equation? Before understanding that, we can take an example of magnesium. As we discussed, there are different methods to represent a chemical reaction. First of all, word equation. In word equation, we are simply using words. For example, magnesium plus oxygen, it gives magnesium oxide. We represent in words. But when we use chemical equations, another method to represent a chemical reaction is use of chemical equations. In a chemical equation, we use certain symbols. For example, burning of magnesium ribbon. We use Mg as a symbol of magnesium. and O as a symbol of oxygen. MgO, it's a symbol of magnesium oxide. In a chemical equation, we use symbols. Mg plus O2 gives MgO. It's a chemical equation. In this chemical equation, let us see how many atoms are there on LHS and RHS. You can see that magnesium is balanced. Number of magnesium on LHS and RHS is 1. But what about oxygen? There are 2 oxygen in LHS, but on RHS there is only 1 oxygen. So this equation is actually not balanced equation. It is not a balanced equation. So a chemical reaction can be represented by a word equation or by a chemical equation. When we represent with a chemical equation, it should be balanced, because law of conservation of mass states that mass can be neither be created nor be destroyed. So the number of atoms on the LHS, it should be equal to number of atoms of a particular element in RHS. So there are certain steps to follow for balancing of a chemical reaction. First, to balance a chemical equation, first draw boxes around each formulae. Do not change anything inside the boxes while balancing the equation. Second step, list the number of atoms of different elements present in the unbalanced equation. You have to list out the elements. How many hydrogen atoms are there? How many oxygen atoms are there on LHS and RHS? We have to list the elements first of all. Later, we have to start the balancing with a compound that contains the maximum number of atoms. It can be a reactant or product. Then make the number of atoms equal on both sides. Here we have an example, example for balanced chemical equation. The reaction between hydrogen and oxygen to give water. This equation is actually balanced. Let us check number of hydrogen atom on the left side. There are 4 hydrogen atoms. 2H2 means 4 hydrogen atoms. 2 into 2 hydrogen atoms. That is 4 hydrogen atoms on the LHS side. See, on the RHS side, there are also 4 hydrogen atoms. So it is balanced with respect to hydrogen. What about oxygen? Oxygen also, it is balanced. Oxygen exists in molecular form in LHS. That means O2 means 2 oxygen atoms. In right side also 2 hydrogen atoms are there. 2 oxygen atoms are there. So this equation is balanced. To make the chemical equation more informative, the physical states of the reactants also we have to mention. For example, hydrogen, it exists in gaseous form, so we have to put G. Oxygen also, it exists in gaseous form, we have to put G in bracket. To make the equation more informative, the physical states of the reactants and products are mentioned along with their chemical formulae. For example, gas, G for gas, L for liquid. AQ we represent it, it is used to represent in solution form. Okay, the word AQ, it is written, it is actually the word aqueous. It is written in the reactant or product to represent a compound in a solution of water. Next, in this chapter, we have to discuss about different kinds of chemical reaction, different types of chemical reactions. Chemical reactions are of different type. First one, combination reaction. Second one, decomposition reaction. Third one, displacement reaction. Fourth one, double displacement reactions. Fifth one, redox reactions. So we got an idea what are chemical reactions. In lower classes we have discussed about chemical changes. Every chemical change is accompanied with certain chemical reactions. These changes are actually permanent change. Okay, chemical changes are permanent change and which cannot be reversed, right? And chemical reactions are of different type: combination reaction, decomposition reaction, displacement reaction, double displacement reactions, and redox reactions. So let us learn in detail about each of the kind of chemical reaction. First one, combination reaction. When two reactants combine to form a product is called combination reactions. We understood what are reactant, the substance which take part in a chemical reaction. For example, in magnesium, burning of magnesium ribbon, what are the reactants? Magnesium and oxygen are the reactants. Okay, so when two reactants simply combine to form a product, it is called a combination reaction. Many examples are there for combination reactions. Burning of magnesium ribbon, formation of water from hydrogen and oxygen. Another example is given here: calcium oxide combined with water to form calcium hydroxide. Calcium oxide combined with H2O or water to give calcium hydroxide. Calcium oxide react vigorously with water to produce slaked lime. This calcium hydroxide is also called slaked lime. Another example, calcium hydroxide reacts slowly with the carbon dioxide in air to form a thin layer of calcium carbonate on the walls. So combination reactions are, definition is very simple: when two reactants combine to form a particular product, a single product, it is called combination reactions. So we will discuss many examples in the classroom. Okay. Reactions are also classified based on the energy transfer or heat transfer. They are called exothermic. Certain reactions are exothermic reactions. What are exothermic reactions? The reactions in which heat energy is released along with the formation of product. So you know that many of the reactions release energy, especially heat energy. When you burn any fuel, we get energy, heat energy mainly. Such type of reactions in which heat energy is released out are called exothermic reaction. Burning of fuel like LPG, burning of CNG, because they releases a lot of energy. Burning of natural gas or decomposition of vegetable matter into compost. There are also examples for exothermic reaction. What are exothermic reaction? The reactions in which heat energy is released along with the formation of product. What are endothermic reactions? Endothermic reactions, those absorb energy. The reactions in which they absorbs energy from surrounding. They are called endothermic reactions. Especially decomposition reactions are endothermic in nature. What about respiration? Respiration is exothermic reaction. Sorry, it is written here endothermic reaction. Actually, respiration is considered as exothermic reaction. What is respiration? As you know, after digestion, the food is broken down into simpler substances like glucose. You know, whether large molecules of carbohydrates during digestion are broken down into the simpler substance like glucose. For example, rice, potatoes, and bread contain carbohydrate. These carbohydrates are broken down into glucose. This glucose combines with the oxygen in the cellular respiration because this takes place in cells. So this glucose combines with oxygen in the cells of our body and provides energy. Since it provides energy, since it releases energy, we have to consider respiration as an exothermic reaction. So here it is written endothermic, actually it is exothermic reaction. So the reaction in which heat energy is released are called exothermic, and the reaction in which heat energy is absorbed are called endothermic reactions. Second type of chemical reaction, decomposition reaction. Decomposition reactions are actually just opposite of combination reactions. In combination reactions, what we have learned, the simple reactants, they combine to form a single product. So here decomposition is actually just the opposite of combination reaction. When a product breaks up into constituent reactants, a single product breaks up to or splits into many. When a single product breaks up into constituent reactants, the reaction is termed as decomposition reaction. For example, ferrous sulfate, when you heat ferrous sulfate crystals or ferrous sulfate salt, see, it's split into three different products. It splits into ferric oxide, sulfur dioxide, and sulfur trioxide. In this reaction, you can observe that a single reactant breaks down to give similar products. This is a decomposition reaction. So the reaction in which a single reactant breaks down to give similar products are called a decomposition reaction. Ferrous sulfate crystals, first when you heat these crystals, they lose the water of crystallization. When you heat further, what happens? They split into ferric oxide, sulfur dioxide, and sulfur trioxide. So decomposition of calcium carbonate. When you heat calcium carbonate, it decomposes into calcium oxide and carbon dioxide. This is one of the important chemical reaction which is used in industry. So decomposition reactions means when a single product breaks up into its constituent reactants. Decompositions are different types. See, in above example, iron sulfate, decomposition of iron sulfate, it takes place when you heat the iron sulfate or ferrous sulfate. You are supplying the energy. So this reaction is called thermal decomposition. If you supply heat energy in the form, energy in the form of a heat, it is called thermal decomposition. For example, decomposition of ferrous sulfate, decomposition of calcium carbonate. These are examples for thermal decomposition. Another example, decomposition of quicklime. Quicklime is calcium oxide. Okay, we will discuss in detail. So if the decomposition takes place by means of electricity, it is called electrolytic decomposition. When the decomposition takes place by the means of electricity, it is called electrolytic decomposition. You learned about electrolysis of water. When the electricity passes through any solution, certain chemical changes will happen. We discussed in class 8, chemical effect of electricity. So when current passes through water, what happens to the water? It split into hydrogen and oxygen. This is called electrolysis, or it's a type of decomposition. A single compound, say water, it decomposes into hydrogen and oxygen. This activity we have done already. For this activity, take a plastic mug, drill 2 holes at the base and fit rubber stoppers in these holes. Insert carbon electrodes. For electrolysis of water, we are using two electrodes. Actually, that is graphite rods or carbon electrodes. Connect these two electrodes into a 6-volt battery. One should be connected to positive terminal, another should be connected to negative terminal. After that, fill the mug with water such that the electrodes are immersed in water. Take two test tubes filled with water and invert them over the two carbon electrodes so that we can collect the gases in test tubes. When switch is in on position, current will pass through the water and you will observe that the formation of bubbles at the both electrodes. Okay, these bubbles displace water in the test tubes. In this reaction, hydrogen is liberated at cathode and oxygen is liberated at anode. So we were discussing about decomposition reaction. Decomposition reactions are actually when a single product split into different reactants. Example, there are thermal decomposition reaction in which heat energy is used. In electrolytic decomposition reaction, electricity is used. Another example of decomposition reaction, photolysis, that is light decomposition reaction. Some of the reactions happens when they absorb light energy, especially silver chloride. Silver chloride split into silver and chlorine on exposure to sunlight. So this is an example of light decomposition, not thermal decomposition, light decomposition. So this reaction is used in black and white photography. The above reaction, the decomposition of silver chloride on exposure to sunlight is used in black and white photography. So we learned that the decomposition reactions require energy either in the form of heat or light or electricity for breaking down the reactants. The decomposition reaction require certain kind of energy in the form of heat or light or electricity. If we use heat energy, we call such reactions thermal decomposition. Light decomposition, when we use light, we call it as a light decomposition, or electricity can be also used for electrical decomposition reactions.